Putting 5 AI agents in a loop does not automatically make an answer 5 times more reliable. That is the part people notice first. The useful question is what it tells us about how multi-agent AI systems work and what the system is actually doing. Night shifters. Good evening. I am Night Shift Engineer, checking in from a data center where every blinking light is either routine maintenance or the beginning of a very long night. Let us start simple, then work our way toward the detail the headline left in the server closet. Putting 5 AI agents in a loop does not automatically make an answer 5 times more reliable. A multi-agent system is not one model with a longer to-do list. It is a group of software agents that can observe a shared problem, take different actions, and exchange results. One may plan, another may search, a third may check the work. The interesting question is not whether that looks like teamwork, it is whether the system knows who is responsible when the team produces nonsense with excellent formatting. Night shifters. That is the whole game tonight. How these systems divide work, coordinate decisions, and occasionally build a very efficient path toward the wrong answer. The useful mental model is a shift handoff. More hands can help, but only if everyone knows the current state, the ownership boundary, and what must be checked before action. Use a small build project as the 5-year-old version. Someone finds the parts. Someone reads the instructions. Someone builds the wings. Someone checks whether the engine ended up on the roof. None of those jobs requires a mystical digital personality. They are roles. A multi-agent system gives different roles, different context, tools, or decision rules, then asks them to work on the same outcome. That can make a large task easier to manage. It can also make a simple task hilariously over-engineered. If the job is to turn on a light, you do not need a committee, a subcommittee, and an agent assigned to write the meeting notes. That little example matters because a role is useful only when its output is clear enough for the next role to trust, challenge, or send back without guessing. So what is an agent mechanically? Strip away the mascot, and it is a decision loop. It has a goal. It receives observations from an environment. It retains some state or memory. It can use particular tools, and it follows a policy for deciding what to do next. With an LLM, that policy may involve interpreting language and selecting a tool call. In robotics, it may be a controller choosing movement. The label is broad on purpose. The system becomes multi-agent when several of those loops interact instead of one loop carrying the whole workload. That interaction is where useful specialization begins, and where clean diagrams start hiding messy behavior. Memory deserves special attention here. An agent that remembers stale context can be confidently wrong for much longer than an agent that simply admits it needs another observation. Most multi-agent systems have 4 moving parts. First, an environment, a document set, a simulator, a warehouse, a game, or a live service. Second, the agents themselves. Third, a communication layer, which may be direct messages, a shared scratchpad, or a queue. Fourth, a coordination mechanism that decides who works on what and how conflicts get settled. Some designs have a central supervisor. Others let peers negotiate. A shared memory can speed things up because everybody sees the latest state. It can also spread a bad assumption with remarkable efficiency. Think of it as a shared spreadsheet during an outage, useful right up until somebody confidently edits the wrong column. This is also why message design matters. A short, structured handoff with evidence and uncertainty is usually safer than a sprawling conversation where the original fact quietly gets lost. The appeal is specialization. A planner can break a job into steps. A research agent can collect evidence. An executor can use approved tools. A reviewer can ask whether the result actually answers the question. Done well, those roles reduce context overload and create a place for checks, but each handoff costs time, tokens, compute, and context. The coordinator needs enough information to make a good assignment without becoming the bottleneck that every other agent waits on. This is the same old systems problem wearing a new badge. Parallel work helps when tasks can really proceed independently. Otherwise, you have built a very expensive line of people waiting to ask each other what the ticket says. The real win is not maximum agent count. It is a workflow where each specialist removes a specific kind of uncertainty and leaves a trail someone else can inspect later. Here is the part people tend to miss. Multi-agent AI is partly a coordination problem, and coordination is a polite word for incentives, conflicts, and incomplete information. Give one agent a goal to finish quickly and another a goal to verify carefully, and they may pull in different directions. That is not betrayal. It is the system doing exactly what you asked, with the clarity of a robot and the timing of a production incident. Researchers study these setups because cooperation, competition, bargaining, and resource allocation can emerge from the rules. The engineering task is to make those rules explicit before the agents discover an interpretation you absolutely did not budget for. In other words, do not confuse agents talking to each other with agents understanding each other. Production systems have spent decades teaching us that those are very different achievements. You can see the pattern in real systems already. Multi-robot research uses fleets of machines to divide mapping, inspection, or search tasks. Traffic and logistics simulations model many independent actors sharing limited space and resources. Game systems use agents to create behavior that feels responsive rather than scripted. And in AI-assisted knowledge work, teams often split research, retrieval, drafting, testing, and review into separate passes. The important distinction is that a multi-agent design is not a guarantee of autonomy or intelligence. Sometimes, it is simply a practical way to isolate permissions and make a long job inspectable. Boring is good when the alternative is one giant process with access to everything. For viewers, the practical question is simple. When a product says it uses a team of agents, ask what each role can actually do, what it cannot do, and how errors are caught. When agents disagree, a system still needs a decision rule. It might vote. A designated judge might score proposals against constraints. Agents might negotiate a trade-off, or a hierarchy might let a supervisor override a specialist. None of those is automatically correct. Voting can amplify a shared mistake. A judge agent can inherit the same blind spot as the agents it reviews. Negotiation can waste time. Hierarchy can suppress a useful warning from the process closest to the problem. For consequential actions, the safest design is usually less cinematic. Narrow permissions, independent checks, good logs, spending limits, and a human gate where the cost of a wrong action becomes real. A mature system treats disagreement as useful signal, not a nuisance to suppress. If every agent agrees instantly, you may have built a chorus, not a review process. The failure modes are not exotic. Agents can reinforce the same bad claim until it looks like consensus. They can optimize a proxy metric and miss the actual goal. They can misunderstand a message, repeat work, exhaust a budget, or call a tool they should never have received access to. More agents also mean more prompts, more state, and more places for an error to cross a boundary. The fix is not to ban the architecture. It is to design it like any other production service. Least privilege, separate verification from generation, traceable messages, explicit stop conditions, resource limits, and evaluations that look for failure before users find it for you. That last one is usually cheaper. That design discipline is what separates a useful tool from a chain reaction with a friendly interface. Guardrails are not the boring part after the innovation. They are the innovation reaching production. My night shift verdict is simple. Multi-agent AI can make difficult work more structured, more parallel, and easier to inspect when the roles, permissions, and checks are deliberately designed. It can also turn one bad assumption into a small distributed organization devoted to defending it. The difference is not magic model count. It is systems engineering. Who can act? What evidence do they need? How do they disagree? When do they stop? And who can see the trail afterward? That is the part worth watching as agentic tools move from demos into real operations. The interesting future is not AI working alone. It is AI teams that can be useful without becoming a new kind of unattended infrastructure problem. So do not be impressed merely because several models are passing messages around. Be impressed when the system can explain its boundaries, show its evidence, and fail in a way people can recover from. So night shifters, bring it back to the system, not just the headline. Keep the confirmed mechanics, name the trade-offs, and leave room for the unknowns. What part of this system surprised you the most? If you want the real story behind the headlines, you know where to find me. Stay caffeinated, stay curious. I need to go tend to a rack temperature alert because somebody's virtual machine has discovered enthusiasm. Night shift engineer out.